Hello and welcome to our Cows and Chaos Feed, Forage and Management Strategies webinar series. My name is Andrea Hansen and I'm a Livestock Extension Specialist with Alberta Agriculture and Forestry working out of the Airdrie office. And I'll be the moderator for this retaped webinar. Barry originally presented this information on August 29th. So this webinar is the fifth in the series of webinars that began in July of 2019. This webinar is entitled Debunking the Myths of Feeding, Alternative Feeds, Salvage Crops, and Unusual Feeds. So with that, I will pass this over to Barry.
Thank you, Andrea. With the weird weather we've had this year, the lack of moisture, excess of moisture, what we're seeing across the province is a bunch of variable conditions where some areas have lots of feed in the field. Unfortunately, they can't get at it to harvest it and bring it in. In other parts of the province, it is dry, which is no different than the last couple of years, and feed is short. So we're trying to see what can we do to reduce the feeding costs this winter and how to use some of the different feeds that are available to producers. So the forages that are available are going to have a variable amount of weather damage, variable quality, and it's not a typical year, to say the least. What Dr. Hughes at the North Dakota State University found out back in the late 90s was if you can reduce your winter feeding costs by $1, you can increase the net profit of the operation by $2.48. So if you look at the multiplier effect that was there in the 90s, it's probably a higher number now. So how do we do the feeding programs for this winter? What can we use? How can we use it? And if I can give you some tips on how to prevent having problems or avoiding problems, that's the intent of this webinar. First thing that needs to be done is you need to test the feeds. Green feed, round bale silage, straw, hay, pit silage, they all need to be sampled so that you know what's available for quality. A core sampling tool is recommended for use because it provides you with an accurate sample. But how do you get an accurate sample? Or what do you want to test for? In most years, the minimum requirement for to get a balanced ration developed after the feeds are in is testing for moisture, protein, calcium, phosphorus, magnesium, potassium, and sodium. So those are the macro minerals and protein that need to be done to give us a good starting point. Acid detergent fiber is an indication of the maturity of the plant. The older it gets, the higher that level is. And unfortunately, as the fiber levels go up, the energy levels, whether it's TDN or the net energy system, whichever one you use, your result will show by mathematical calculation that as fiber levels go up, energy levels go down. Neutral detergent fiber is used for estimating the total dry matter intake that an animal can consume. So for a beef cow, if you get above 1.2% of their body weight intake of neutral detergent fiber, that's when they're full and they're going to stop eating. Now, with people rushing to get hay baled this year, some of it wasn't cured, and you'll find that in some situations there are bales that are heating. They smell like tobacco or have a very sweet smell, even though they're not under plastic, so they're not truly silage, they're heating. And what that happens when temperatures get above 35 to 40 degrees Celsius, the heat process binds some of the protein available in that hay to the fiber, making it unavailable to the animal. So you need a secondary test, acid detergent insoluble N, to see what protein is actually available to the cow. Nitrates, if you're looking at a hail or a frost situation, or if you're salvaging a canola crop or an annual crop that had high nitrogen fertilizer application, pardon me, testing for nitrates is a good idea. The other thing if you're using the cover crops or the companion crops that are becoming popular right now, and you've got canolas or brassicas or turnips in the stand, you need to test for sulfur. If your total sulfur content in the ration exceeds 0.4%, then there's the potential for having problems with polio. So I get asked, well, I'm just going to take a grab sample of my forage after it's baled, and I'm not going to bother with running a core sampling tool. From the slide, you can see that there's a significant difference in quality, especially in the energy and protein levels, if you use a grab sample compared to a core. If you've taken a handful of hay or reached into a hay bale in the middle of winter, there's snow on the ground, when you pull that material out of the bale by hand and you look on the ground, you'll see a whole bunch of leaves and green material on the snow. That's the gravy. That's the really good part of the forage. It has the protein, the energy in it as reflected by this result. So all you're going to be doing by taking a grab sample is underestimating the quality of the feed, and that will in turn cost you more money, because when you balance the ration, you're going to say, well, I need extra protein, I need extra, so you're going to be using canola meal or peas or a 32% to supply the extra protein. And then to make up the difference in energy, you're going to need to feed grain, either corn or barley or oats, whatever you're using. And every time you do that, you're increasing the cost of your ration. For the mineral side of things, there's two different ways to go. You've got the traditional wet chemistry, which has been around for years and years and years. And there's a newer system which has been out for about 15 to 20 years called near infrared spectrometry, or NIRS. Now, NIRS is great for fibers and proteins, no different than wet chemistry, but when it comes to the minerals, the numbers can be out by 200, 300%. So there's no point doing it if you don't have an accurate result. So if you look at your calcium and phosphorus levels, and magnesium levels in particular, those are the three big ones for downer cows, winter tetany, milk fevers, for example. If I was using the NIR numbers, I'd be adding maybe an ounce and a half of calcium just to get my 2-to-1 calcium to phosphorus ratio. If you look at the wet chemistry amounts, you can see that the values are much lower. The phosphorus level is right at the minimum to meet requirements to fix the calcium to phosphorus ratio so that you have 2 parts of calcium to 1 part phosphorus. You're going to need to add about 4 ounces of limestone per head per day, and magnesium should be above 0.2%, so you'd be needing about an ounce of magnesium oxide as well to balance those rations. So it makes a big difference on the accuracy of the results. If you have a choice, when you go to the lab, ask for the wet chemistry on the minerals. So what you want to do is you want to compare your test results on a dry matter basis. So an example I'm using here is you've got test results from an alfalfa grass hay and barley silage. And on the test result, on the as fed side of the column, you're getting a 15% moisture content in the alfalfa hay and 12.8% protein. For the barley silage, 65% moisture and 4.2% protein. So how do you compare one against the other? You need to remove the moisture. So what you're doing is, if you've only got 85% dry matter, you divide your protein content by the percentage of dry matter. In the case of the alfalfa, it's 12.8 divided by 0.85, giving you a 15% dry matter content. The silage doing the same thing with only 35% dry matter, 4.2 divided by 0.35 brings you up to a 12% protein content. This way, instead of looking at apples and oranges, you've got apples and apples, and you can make a true comparison. And this can be used for any of the nutrients or just look at the feed test results and always use the dry matter basis for when you're comparing samples. The reason I'm emphasizing protein in this example is protein is critical to maintain bacterial populations in the rumen. They digest the feeds, they break down the fibers, make the feed particles small enough so they can pass into the lower digestive system. And what happens is if you've got a low protein intake, you've got a protein content of 5 or 6%, that's not sufficient to maintain microbial populations. So when that happens, the lack of protein reduces the ability of the microbes to repopulate. Some of them only have a 20-minute life cycle, so they have to repopulate every 20 minutes. So if the protein's not there, their cycles slow down, the numbers of bacteria slow down, so they can't digest the fiber as efficiently. It's going to take them longer. You've got the feed resources staying in the rumen longer, therefore there's less room for them to eat the next day. That in turn is going to reduce your protein intake even further. So this is a negative feedback loop that definitely will create problems, and if it gets bad enough, you can have impaction. So if when you do start providing extra protein, it'll take a couple days, 3 days for the rumen bacteria to respond, and you'll see an improvement in manure quality, and feed intake should go back up. Value of protein, again, you can use this for any nutrient as well. Two of the standards that are out there right now, canola meal versus feed peas. These numbers were taken from the weekly feed grains listing on Roping the Web. Canola meal, for example, is $290 per ton right now, 38% protein. So in a metric ton of canola meal, you're going to get 837 pounds of protein. If you divide the cost of the canola meal by the number of pounds of protein, it's costing you 34 cents per pound of protein within that supplement. Feed peas, on the other hand, 240 a ton. Their protein content is only 24%, providing you with 528 pounds of protein per ton, and the net cost would be 45 cents. So you can see that even though it's cheaper by ton to buy the feed peas, in the long run, if you take into consideration the concentration of the protein, you can see that the peas are more expensive. Some of the other byproduct feeds that you can use: corn distillers, wheat distillers, barley malt sprouts, screenings, stillage. They're all great products. A couple things to watch out for is your calcium levels are usually fairly low in these products, just because of the nature of what they are. But your phosphorus contents are typically 2 to 3 times higher than normal. So if you were able to use barley grain last year and you want to use corn distillers and you were using a 2-to-1 mineral, in this case, again, you're probably looking at adding that extra 3 to 4 ounces of limestone rather than a 1-to-1 mineral or a 2-to-1 mineral, because your phosphorus levels will be more than adequate with what's being supplied from the grains. Now, the urea at 281% protein, that is your 4600 fertilizer. There is an additional scrubbing process on that for feed grade urea so that they don't have any traces of heavy metals in there, which can cause problems. Maximum increase in protein by urea is roughly 2 to 2.5% of the total ration. And if you are using urea, you need to feed 2 or 3 pounds of grain a day to utilize that nitrogen efficiently, and calves under 450 pounds do not use urea. So if you're under that 450 pound range, you need to use an all natural source of protein, which all of these are. Or if you're buying a 32% supplement or a 20% supplement, you need to have an all natural. So it'll be a 32-0 or product, or a 20-0 rather than the 32-18, which means 32% protein total, 18% of that coming from urea. So be careful on the product that you're purchasing. If you're using an unusual or byproduct ingredient, how consistent is the product? Some of the problems that we've seen with example screening products coming from different plants, some of them are better quality than the others. A lot of times it all depends on the product that's coming into the mill or into the elevator, and what you get coming out the other end as the screenings product depends on what came into the elevator or into the feed mill. Is that product going to be available, or are you going to be halfway through the winter and then they say, I'm sorry, we can't bring you a load because we're out, and then supply is not going to be available for another 3 to 4 weeks? You need to have that consistency of supply so that your animals are not changing rations halfway through the winter. How far do you have to truck it, or what's your cost of freight? Is it a bulky product that will bridge in a hopper bottom bin if you're using that type of a system, or does it have to be laid out on a concrete floor and handled with a front end loader? Will a 4-inch auger work versus an 8-inch if you're taking it out of a bin? The other side of the side of ease of handling is not only the physical handling attributes, it's what happens to you, the operator. One of the worst products that I've run into over the years is, I'm just going to go back to when I was on the farm, the oats. When you're hauling oats or handling oats, the dust on the back of the oats is just incredible. Same thing with the distiller's grains. I finally remember what I wanted to say. So is it going to be something that you want to handle and are willing to use, or not? Those are some of the considerations that have to be taken into account. The other side of the equation is cattle can do very well with less feed as long as their nutrient requirements are met. In 2002, there was a severe drought for most of the province. And what they did at Ellerslie was they brought in corn, because barley was very expensive and not available. It was cheaper than hay. And they limited the hay intake to 0.5% of their body weight. So it restricted their feed quite considerably. They fed corn to meet the energy requirements. You can do the same thing with barley and oats. And they provided the supplemental protein and minerals in a pelleted form. What they found was that the cows did very well on the lower volume of feed for the winter. And these are pregnant cows. Feed costs were reduced dramatically. The management had to be stepped up a little bit to monitor. Some cows were not quite as aggressive getting to the feed bunk, and with limited amounts, the boss cows got more than what they were supposed to, or they're more than their share. And the more timid ones started to lose weight, so they were taken off and put into a separate pen and fed differently. You need to protect them from the wind and the snow to minimize energy losses to the environment. And the cows made it through winter well, no problems with calving or milk production, and it was a system that worked very, very well. Now, grazing a crop aftermath, be it chaff piles or chaff and straw, or your Timothy aftermath or forage seed production aftermath, generally you can get any place from 20 to 60 animal days of grazing per acre. And that's typically for the chaff piles behind a combine. So the quality of that chaff will depend on how many weed seeds are present, how many kernels of grain have been thrown off the back end of the combine if the wind was set high to throw out the lightweight kernels if you're trying to keep your sample weight up, and also the maturity of the crop. If it was fairly green when the crop was cut, the value of the straw or the value of the chaff will be higher than that's of something that is very, very mature. It is a low protein product. Dry cows in mid-pregnancy typically do okay on that. If you're going into late pregnancy, you're probably going to have to supplement some extra protein to the ration and probably some extra energy. But they're also, this product is notorious for being low in calcium and magnesium. So mixing a salt mineral combination together so that they get roughly 4 ounces of limestone and an ounce of magnesium oxide per day, along with their 1.25 ounces of salt and the vitamins, would probably be the way to go in something like that. It's going to be difficult getting them to eat the calcium and magnesium. Calcium is very dry, or dries out the mouth and a very chalky tasting. Magnesium is bitter. So you're going to need to add 5 to 7% dried molasses into the mix by weight to sweeten it up and enhance them to eat it. The forage seed aftermath and cereal straws generally have a protein content of only about 4 to 6%. And you need a minimum of 7% protein to keep the rumen functioning properly. These type of products here are great fillers for rations, cows in mid and late pregnancy, mature bulls, but it's not suitable for lactating cows or young calves. Intake will be limited by the neutral detergent fiber of the product, and expect this to make these types of products to make someplace between 25 and 40% of the total dry matter per day. So supplementation with either hay or silage in the field or some grain is probably going to be required. Pea straw, it's a higher quality product than cereal straw. 2, maybe 3% higher protein content than oats or barley straw. It is a legume, so it will have a higher calcium content. The peas themselves, or the pea straw itself, has a different taste than cereal straw. So if the cows have not experienced it before, it might take them a couple, 3 days to get onto the feed. The other thing that's a possible advantage of using pea straw, sometimes some of the pods are not shattered during the combining process, or peas are thrown back out over the back end of the combine. When you get the peas into that straw, the feeding value just goes up accordingly. The one I don't want to spend much time on, but just to make you aware, flax straw is a plant that is extremely high in fiber, probably the lowest quality straw that there is. Some people might want to try it. The problem is, if there's any green straw in that windrow from the flax crop, it could contain prussic acid and you could poison the animals. So that's one that I would use as a last resort, and have the straw tested for prussic acid before you even consider using it. Canola straw, it's got quality someplace between cereal straw and pea straw. A little more protein, higher calcium levels than cereal straw. The unusual thing about this is cows just go after canola straw. If you try to use it for bedding, it usually is gone by the morning. It's got a hollow stem. The one thing you do not want to do is run the bales of canola straw through a processor when you're feeding, because it's like running the canola straw through a rotary combine again. There'll be nothing left but dust. So just put it in a feeder and let them pick at it for what they need, and it can work very, very well, again, as a filler. So there's your general composition differentials between the straws. You can see the differences in protein. Calcium, especially on the pea and canola straw, is much higher than what you have in the cereal straws. Phosphorus levels are generally about half of what the animal requires, so extra grain or a 2-to-1 mineral is going to be required. Magnesium values are variable, and energy content is about the same across all three. Cost, we should know what's going on there by the middle of October, first part of November to see where the prices stabilize at. Weeds, if you've put in a crop of a forage crop and you did not put a cover with it, you're going to have a lot of weeds. Taking that first cut early when the weeds are immature will provide you with a high quality forage. Variability in quality, I would say limit that to 20 or 25% of the ration to be safe. If you've sprayed the fields and you didn't get a good kill on the weeds, observe the 30 or 60 day withdrawal pre-harvest interval that's on the label. It depends on which product you have. Observe those restrictions so that there's no problems later on. Now, some of these weeds can contain oxalates, which will tie up calcium absorption and cause photosensitivity. Nitrates, again, can either reduce performance or kill animals. Alkaloids cause photosensitivity. So knowing what weeds are there, double check to see if there are any cautions on either animal intolerances or toxic principles present in the weeds. Kosha, Southern Alberta, Southern Saskatchewan, they've been using this as a feed for years and years and years. Cut early. It's got protein content similar to that of a good quality alfalfa grass hay. Makes a nice feed, but oxalates are a concern in that, so this should not be more than 25% of dry matter intake. Can also be high. It is also a nitrate accumulator. So testing this for nitrates is a good idea. Oxalates binds calcium, so it's not absorbed, and that calcium has to go out someplace, so it can cause blockages in the kidneys and in the urinary tract. With downer cows, milk fevers, winter tetanies are problems if that calcium situation is not rectified. If you have a high level of nitrate or oxalate, the physical symptoms will show up within 2 to 4 hours if these cows go in hungry, labored breathing, depression, weakness, convulsions, lockjaw. I think it'll take a little longer to show up with lockjaw, but the labored breathing, depression, and weakness and convulsions are something that, watch the cows once you turn them into a field of kosha if you're grazing it. Canola green feed or silage. Your highest quality is typically at the late bloom to early pod stage. Treat it the same as a high quality first cut alfalfa grass hay. Cows go after this stuff like crazy, either as a green feed or as a silage. And it can be fed as the sole ration as long as nitrates are low, polio is low. If the plants are a little bit more mature and the pods have been there for 3 weeks, the seeds are developing within those pods. There's probably 25% oil at that point in time. If your total oil content in the ration exceeds 7%, rumen function is impaired and rumen contents will not turn, so it will cause a bloat situation if there's too much oil. 2- and 3-year-old hay, all the vitamin precursors for the A and E have been oxidized out, and you need to supplement 100% as soon as you start feeding this product. Bales can be 200 to 300 pounds lighter than when they're made, so if you're buying it from somebody else and they said, well, the bales weighed 1,400 pounds and he wants so much a pound, have those bales reweighed, or at least a couple loads reweighed so you've got an accurate weight. The quality is definitely going to be down. Water damage to the outside edge of the bale, that outside 4 to 6 inches, It's going to reduce digestibility and voluntary intake, but you're also probably going to see 2 to 3, 4% reduction in protein content, and probably a 5, 6, 7% reduction in the total digestible nutrients or TDN content of that feed. Fiber levels will also go up. When you're looking at using straw as a ration, cows in mid-pregnancy, 20 pounds of straw, 1.25% of body weight is a safe limit. You can sometimes can go up as 1.5% of body weight, and I wouldn't go any higher than that for straw. So what you can do in that situation, 20 pounds of straw, 15 pounds of green feed. You're going to need some extra protein, the vitamins and mineral. Back to the same thing, straw and green feed are typically short of calcium, so you're going to need roughly 4 ounces a day for that. Magnesium will be low, so you're going to need another ounce of magnesium oxide. When you get to late pregnancy, the last 90 days, your nutrient requirements go up, so you actually have to switch what's going on. So instead of 20 pounds of straw, you're going to need 20 pounds of green feed. Reduce the straw to 10 pounds to keep your energy and protein levels up. And you continue on with the mineral package for supplementation the same as you did before. Lightweight grain, this was work done again back in the late 80s by Gary Matheson at the University of Alberta. They compared using barley that 34, 47, and 51 pounds per bushel. What they found when they were feeding it to animals, there was no reduction in performance as long as the bushel weight was higher than 42 pounds. So anything from 42 to 51 pounds, there was no difference in performance. But when you got below 42 pounds, there's a 1% drop in performance per pound of bushel weight. So if you're feeding that 34-pound barley instead of 42-pound barley, you need to discount efficiency by 8%, or in other words, you have to feed 8% more grain to get the same performance as what you would with a 47-pound barley. When they looked at steam rolling and dry rolling the barley, there was no difference between the two. If you feed your barley whole to cows that are or to animals that are more than 700 pounds, you're going to have someplace between 12 and 15% reduction in digestive efficiency. So basically what the big advantage is when you're looking at a lightweight barley, and I've chatted a bunch of this stuff already on the screen, but if you're buying the barley from a neighbor, or if you try to sell a lightweight barley to an elevator, there will be a price discount for that lightweight grain, and that typically starts at about 46 pounds. And the discount the last time I checked was roughly $5 per ton for every drop in bushel weight below 46 pounds. So if you're looking at 42-pound barley, that could save you $20 a ton, or roughly 50 cents a bushel in the cost of buying that grain. So there are options here to reduce your winter feeding costs by using the byproducts and some of the less common feeds, or even trying to use some of the off-spec grains. Now, feed wheat, it's something that can be used. It has a more rapid digestion rate than barley or corn. The maximum processing that you want on those grains, and you have to process wheat for any of the animals that are eating it, you improve your digestive efficiency by 25% if you break the kernels into 2 pieces. If you go more finer than that, you're going to have troubles with acidosis and bloat. Now, your protein and energy level is higher in wheat than oats and barley. Wheat, 10% higher energy than barley, and barley's 10% higher energy than oats. And the protein content in wheat can be any place from 12 to 15%. So need to figure that one out. For large animals, mature animals, 6 pounds of wheat a day is their maximum amount that's recommended. And to anything under 700 pounds, 3 pounds or less. So it's a gradual increase from 7 weight to 1,300 weight. You can gradually increase your wheat up to 6 pounds. And as it gets less than 700 weight, you need to drop that wheat down a little bit more. So if you're only at 500 or 400 pounds, you're probably looking at 1.5 pounds or 2 pounds of wheat as the maximum limit. Oat hulls, a great byproduct from the oat milling industry. There's a plant northeast of Edmonton at Namao, and basically they're cleaning oats and scalping oats for horse products that are being exported into the States or around the world. So it will contain hulls and broken kernels and small kernels, but the feed typically is good in energy, good in protein, and the cost is much less than what you'd have to pay if you're buying grain. So if you want to use oat hulls, again, 25–30% of the ration is a possibility as a substitute for some of the grain, but again, each load may be a little bit different, and you have to be careful in what you're doing. Grains or screening pellets. Chatted a little bit about this earlier. The quality can depend on what's in the pellets. A 30% grain pellet is not the same as a 100% screenings pellet. It's typically a higher quality product, and it's going to cost you more. The one thing that you cannot see when you look at a grain screening pellet compared to whole grain is if there's ergot contamination in whole grain. You can see the banana-shaped gray kernels in the sample. When they make the screening pellets, they run the grain through a hammer mill and then put it through a pelleting system, so you cannot see if there was anything there. Energy values, ask your salesman, see what they estimate the energy density of that product can be. Some can be very reasonable and roughly equivalent to that of oats, and some are no better than hay, depending on what's in them. Urea, going back to that again, no more than 25% of the total protein in the ration can come from NPN, and sometimes they do go ahead and put urea into these screening pellets to get you that 20% protein. If you can, have an ionophore fed when you're feeding the pellets and some of these grain products. It'll improve your digestive efficiency by 6 to 7%. It also helps stabilize the rumen so you have less troubles with bloat and acidosis. Going back to the ergot, the old rule about 10 years ago was that if you had less than 1 kernel per 1,000, everything was good. With the research that's going on at the University of Saskatchewan, they're finding that that number is out to lunch and is no longer valid. You need to test for the 7 aflatoxins or mycotoxins rather that are present in that system. And there's a good lab in Saskatoon at the vet college that can, at the University of Saskatchewan, that can do the testing for you. Now, a lot of times when you look at ergot, you always hear about the frozen ears or sloughed off hooves or the lack of hair on the tails or abortions. Those are symptoms that occur after 4 to 6 weeks of feeding of a high product with high levels of ergot. The first symptom of having a high ergot content is feed refusal. After 2 or 3 days, they'll just refuse to eat the pellets. If that happens, talk to where you bought the feed from. Adding the ionophore, again, in these screening pellets is cost effective. Dried distillers grains with solubles, maximum of 20% of the grain mix, partly due to the high protein content. They're usually in that 35 to 40% protein, so no use putting too much in there. But the bigger one is the high phosphorus content. It can be up to 1.2%. So the calcium phosphorus problem is going to be there. So often the price of the distillers grains, wheat distillers up to 42%, corn distillers 30%, the price is much better than using a 32%, but you have to offset that because you've got vitamins and minerals and trace minerals in those supplements, maybe even an ionophore. So it's not just what the dried distillers is costing you, but is it going to be another 10 cents or 12 cents a day to put those materials back into that ration that were usually contained in the 32%. Barley malt sprouts or malt sprout pellets, depending on where you're getting it. 26% protein, high phosphorus again, reasonably good energy content. Calves tend to like this product. Helps them get onto feed. Maximum inclusion rate of 25% of the ration. Hail damage crops. This is a Pandora's box. The quality that you're going to have after the storm depends on the stage of the crop, how big the hailstones were. So it can be anywhere from, okay, it's not bad, to basically not better than straw. So feed testing is a priority. If the crop was heavily fertilized with nitrogen, or if you've been using the same land for swath grazing for 4 or 5 years, or bale grazing on certain land pieces, you need to check for nitrate levels in the crop because they will accumulate in this situation. So your choice is either to cut it within the day or 2 days of the storm, or wait up to 2 weeks. Your maximum nitrate content will be roughly 4 to 5 days after the storm. Depending on how many leaves are left on the stems, you may have low soluble sugar content, which will slow down the ensiling process, and it may, instead of taking 3 to 4 weeks for the product to ensile properly, it might take 4 to 5 weeks. The regrowth on these hailed crops is typically very high quality forage. When they grow back and the plants are actively growing, there's no concern with nitrates, and it makes great stuff, great feed for late fall grazing. Bakery or confection waste, more common in Eastern Canada to be used as a supplemental feed. The cookies, the breads, the cakes, the donut products, anything from McGavin's or Weston or wherever is making the breads can be used. You're using a high quality wheat in the flour, so it's going to be a high quality protein product in the feed, so it will work well. Again, it is a wheat product, so that it'll be fast. The digestion rate of the wheat itself, because it was ground so fine, will be even faster digesting than wheat broken into 2 pieces. So slow introduction rates and gradual introduction. Some of these cookies and cakes and donuts that are covered with chocolate and sugars, very fast digesting carbohydrates, which can cause a reduction in pH and acidosis. So be careful on how much you're using, and use a gradual increase in what you're feeding. But again, going back to the slide where it says, do you want to use this byproduct? The consistency of supply and quality is especially critical for this product. Cull potatoes, 9% protein, low calcium, low phosphorus. A good product to use, same energy density as barley. To prevent the problem of choking, what people are doing is putting these potatoes into a silage bag, having the silage bag on a slight slope so that one end is lower than the other. Letting the potatoes ensile, you'll see the bag droop and squat, and at the bottom end or the lower end of the bag, there will be water accumulation there. So what you want to do is cut a small hole in the bottom end of that bag to allow the water to drain out. When the draining has finished after 4, 5, 6 days, maybe even take a little bit longer depending on the temperature for ensiling. Seal up the hole. It's a good way to prevent the potatoes from spoiling in the summertime in warm conditions. Again, limit your intake to about 25% of the total dry matter intake. The only thing that you have to watch out for is if the potatoes have been laying out in the sun for a period of time and you can see a green color on the outside of the skins, that green color contains solanines, which is a glycoalkaloid. So if you see the potatoes are nice, either red or white without any discoloration, they'll be good to use. If they're green, I'd be tempted to pass on that batch of cull potatoes. Ionophores helps increase digestive efficiency by 5 to 7%, maintain a constant rumen function. So these are both good products to use when you're using some of these unusual feeds. Bovatec, if you can feed that on pasture-free choice. Rumensin does not have that registration. There are limited amounts of what you can feed, and if you feed too much, it'll kill off too many of the certain type of rumen bacteria, and your feed intake will go down. The only thing I have as a concern is don't let the dogs and horses get close to these products, especially the rumensin, because they can, if they eat this product, they can be killed by it. 4 to 1 return on investment. For every dollar you spend, you'll probably improve your net return by about $4 right now. So it can be put into pellets, it can be put into supplements so that you don't have to handle it as an individual ingredient on the farm. Cautions that I would like to express at this point: nitrates on ruminants. Basically, if you've got a high level of nitrates, and a lot of the feed test reports coming back are indicating that 0.5% is toxic. That is not correct. You can go up to 1% or higher if with a proper adaptation period, which will take roughly 7 to 14 days. Light frost, high fertility are the main cause. Nitrate is not a problem after a killing frost because the plant is dead and it cannot translocate nutrients up or down the stem. The other misnomer that's out there is I've got a problem with alfalfa being frozen, and I've got nitrates there. Nitrates and any legume plant do not accumulate nitrates because they've got nodules in the root system. So don't be concerned about nitrates in the legumes. Molds and mycotoxins, it's tough to know what to test for. Sending the sample away to a lab and getting a plate count saying I've got so many CFUs or coliform forming units per gram, basically how many bacteria are on the 1 gram of feed, that number doesn't give you any important information. It just tells you that you've got a contaminated feed. The mycotoxin screen from the Prairie Diagnostic Services out of Saskatoon is the one that does a really nice job. You can get it done at other private labs, but I'm not sending you one way, but compare the cost if you are investigating, and I've found that these guys are pretty reasonable. Urea supplementation, if you are using urea, you need to have a minimum of 0.15% sulfur in the ration. When you're feeding natural proteins, there's always some sulfur in there. With urea, it's broken down to ammonia, and then the ammonia plus the sulfur is used to recreate the amino acids and the proteins. So without the sulfur, there's 4 essential amino acids that will not be formed in adequate amounts. That'll affect the ability of the animal to lay down lean tissue. Minimum of 3 pounds of grain per head to utilize the urea, and watch the body condition. Ergot, starting to hear a few things this year with ergot being present because of the wet conditions. These slides are from Dr. Evans out of Missouri, Columbia, and just some nice pictures of what the different types of ergot bodies look like. Typically gray, bent like a banana, twice to 3 times the size of a normal seed. And what will happen is it will cause gangrene in the feet, tails, and ears. The problem in the States is they can get the 2 forms. One's a gangrenous form and a nervous form. The type of ergot we have in Canada does not produce the mycotoxins needed for the nervous form, so it's only the blood flow restriction that is the problem. It'll reduce milk production, reduce growth and feed consumption, cause abortions, and these symptoms unfortunately are not reversible. Ergot, fusarium, levels. Basically what we're looking at here is for the ergot alkaloids, you need to have less than 200 parts per billion as your threshold for when you're going to start seeing problems with ergot. Fusarium and vomitoxin produces a pinkish white fungal growth. It affects protein synthesis in the monogastrics. The reason it's called a vomitoxin, if the pigs and chickens eat grain that has contamination with the fusarium, it will cause them to vomit. Pigs only can take 1 part per million before their feed intake is reduced. For yearling heifers, they can go up to 37 parts per million. Glycosides are present. This is something that has to be evaluated on a case-by-case basis, so it's hard for me to give any definitive answer. But the one thing that I have gleaned from the crop guys that are here is if you had fusarium present in a field this year, you need to feed something other than a cereal crop in there next year, and possibly even rotate it to forages for 3 or 4 years to eliminate the problem. T2 and HT2 mycotoxins, they're formed when fusarium is present. And what these 2 mycotoxins do is they destroy the hairs in the gut linings that are responsible for absorbing nutrients. So you're reducing the ability of the animal to absorb the nutrients from the feed. It also reduces bone marrow development, and that in turn reduces immunity. They are estrogenic compounds, so basically if these are present, the cows are on a form of birth control pills, and they may cycle or they may not cycle, and if they do, it may be a false heat as well. Causes damage to the nervous system, skin disorders. Feed refusal, again, is one of the first symptoms of high levels. Your maximum content for the HT2 per billion, that's with a B, and 1,000 parts per billion or 1 part per million is the limit for the T2. So it doesn't take very much for these things to really create a problem. Sulfates in water. The work done in Saskatchewan in 2017, they went ahead and sampled 2,000 samples of dugout water, and they found that 40% were good, 12% were in the range where you had to be careful whether to use it or not, and almost half of them were not acceptable for use for grazing cattle. Temperature, water, and water intake and sulfur in the diet. If you look in the guidelines, water quality guidelines put out by the federal government, they're saying that 2,000 parts per million is about the maximum limit of sulfur in water. And I'm going to use that as a guideline. You're assuming that you're going to have a certain amount of sulfur being available from the feedstuffs, roughly about 0.13, 0.15%. So if you've got a cow, lactating cow out on pasture and it's fairly nice out, 25 degrees, she'll drink roughly 63 liters of water a day. If you consider that 0.13 to 0.15% sulfur coming from the feed and the sulfur content from the water, you can see that 2,000 milligrams per liter at that point is satisfactory. The cows can do well. 3,000, you're up at the red zone. You're going to have problems. But if it gets warm and temperatures are in that mid-30s range and they're doubling the water intake, you can see that even 2,000 parts per million sulfur in the water is going to get you above that threshold. So it's a floating target depending on how much water they're drinking on a daily basis. You need to mix salt, minerals, and vitamins together. Cows have the knowledge or the ability to recognize that they need salt, but they don't recognize any of the other nutrient requirements. So mix them together. Cows will consume 75% of the salt and mineral at night. So if you're finding that you're not getting enough uptake by the animals, put another salt station in the loafing area. They can consume up to 4 to 5 ounces of mineral salt and vitamin per day, but the trick is you need to put something in there to improve the taste. If you add in roughly 7% dried molasses to the mixture, wheat shorts, wheat mids work well, but what you need to do is mask the taste of the calcium and mask the taste of the magnesium so it's more appealing to them. And all these things are going to do is sweeten it up and make it more acceptable by the animals. Vitamin A, D, and E. Most supplements and vitamin products are great for vitamins of level A and D, but generally not sufficient in vitamin E. In the injectable products, the injectable vitamin A and D, all you're getting is enough vitamin E in there to prevent the oxidation of the other minerals. So there is a product available, vitamin E, 50,000 IUs per kilogram, that you can use for home mixing. And when you're looking at rations, for cows pre-calving, you want 300 IUs per day. For cows that are lactating and for feeder calves, you want 500 IUs per day. And if you are looking at feeding extra vitamin E for the first 2 weeks after you've weaned your calves, those levels should be up to 1,000 IUs per day. Salt at night, we mentioned that one. The blue or red salt do not contain any copper, manganese, zinc, and selenium, and they are deficient in Western Canada. And these 4 micronutrients impact growth rate, reproduction, and immunity. So if you can, next time you're in town buying salt, either use a high trace mineral or a fortified trace mineral salt with selenium. Typically the blocks are brown and green. There has been some supply problems with selenium in the last few months. So when you're buying your salt products right now, make sure that they have selenium included. That's about all I have for today. My contact information is on the screen. If you've got any questions or concerns, feel free to contact me either by email or by phone. Back to you, Andrea.
Okay, thank you very much, Barry. That was great information. Is there anything, just as a question, is there any point that you'd like to emphasize before we wrap up this webinar?
Using these different feeds is no different than farmers trying to grow canola 40 or 45 years ago. Start off small, try a little bit, and don't be afraid to ask for help. The feed mill nutritionists, extension people such as yourself and myself, talk to even private consultants, ask for help when trying to use these different products, And the other professional that should be involved with this whole process is a veterinarian, because sometimes their trained eye can see something before I can.
Excellent advice. Thanks, Barry. So thank you all for your interest in this series, and be sure to check out the other taped webinars, or even better yet, register for the upcoming webinars to watch in real time and ask any questions that you might have. If you have any other topics that you would like to see covered, as it shows on the screen here, please feel free to contact the Ag Info Center and Barry and let them know what you would like to see as a topic. With that, thank you very much again, Barry, for your information, and I look forward to the next session.